7, we have two different streams of cash flows, Company A and Company B. The first one is 11,600 received 3 years from today that grows as a perpetuity. The second one is minus 13,000 received 2 years from today, and it continues as a non-growing perpetuity. Assume the discount rate is 12%. What's the present value of each cash flow stream? Okay, let's get a new page. All right, let's do, what does he call it? Stream A, time 0, 1 equals that, plus 1. And let's call this stream B. And I'll put it closer to the middle because I always do that. Discount rate, 12%, 0.12. Make this a little wider. All right, 11,600 and it grows at 4%. I'm going to put the growth rate up here. And it starts in 3 years. Now, we don't, this is a perpetuity. Oops, so I have to lock that. This is a perpetuity, so these numbers are not as useful in the long run, but we will use this to create our analysis. Okay, let's do the second one. The second one is minus 13,000 in 2 years. And it doesn't change, it's just the same perpetuity. Okay, so the way that we're going to do this is we are going to get the value of these perpetuities if you're standing in time 0. But to do that first, we need to discount them back. And remember when we have our timeline, 0, 1, 2, 3, 4, oops, 4. If we have a perpetuity, the idea is that we are standing here at time 0 and that the cash flow starts in time 1. So the present value of this perpetuity will be in time 0. And this is a growing perpetuity, so it's going to be and to do that, it's a little hinky because the lines are weird now, but let's pretend that it's okay. Okay, so this is going to be that divided by R minus G. So this is the present value at time 2. To get the present value, and notice that this takes care of all of these cash flows forever and ever and ever. That 145,000 takes care of those. So I'm going to get rid of those. And I'm going to say that the present value, so we have 0 cash flows otherwise. 0, 0, all of these are 0. Because this 145 captures all of this stuff in here that we just blacked out. So all we have to do is cash flow divided by 1 plus the discount rate. And I'll lock that to the power of time. Notice all of these are 0, so this is the only one that matters. And let me add another column just to be precise. The NPV is going to be 115,000. Okay, so now let's do stream 2. Stream 2 is a non-growing annuity. So, perpetuity. Non-growing is just C over R. And again, we're going to do it the time period before the payment starts. So it's going to be that divided by R. And let me make all these cute and number-like. Okay, So again, this number, this 100 minus 108,333, that's all of these cash flows. We don't have to think about those anymore because the perpetuity takes care of it. So I'm going to make those go away. This is the cash flow column. This is the perpetuity column. And then this is the PV and NPV. And again, these are 0 because there are no other cash flows in this stream. It goes on forever. To get the present value, we do that divided by 1 plus the discount rate. Lock that to the power of time. There are no other cash flows, but I'll drag it down anyway. And the NPV of cash, or of stream B, and I'm going to delete some of this stuff just so it's, so we have 115 and 96,000. Let's see if that's what we got. 115 and minus 96,000. Okay, so we got that. So then the question is, there are two streams of cash flows. They're combined and they're called Project C. What's the IRR of Project C? Well, here we have the present value of these two cash flows. So we can call this Project C. Oops. Project C is going to just be this plus this. You can do it where you add across the rows, but the easiest by far is just to do this. Let me make this like bright green or something. Okay, so we combine the cash flows. What's the next question? What's the IRR? And then what is the correct IRR? So he finds two, 16.9%, 23%. I actually found 3. So what I did was I went to Data, What If Analysis, and Goal Seek. To find the IRR, you're going to set the value of Project C, which is M5, equal to 0 by changing the discount rate. Okay, let it run for a minute. We end up with 16.899 something or other percent. And if you look, 16.9 is one of the solutions. The other one, there's a typo here. It should be, oh, it just skips the lines. It should be negative 23%. Okay, so if you start with negative like 30%, oops, negative 0.3, and then do a what if analysis and goal seek, change M5 to value 0 by changing cell E1, hit OK. We end up with negative 0.23, which is exactly what's in the homework. But here's another one. Start with 40%, do another what if analysis, change M5 to value 0 by changing E1, hit OK, let it run. We end up with like 3,700%. No, it's 3,800%. Actually, it's more than that. I always get the units confused when it's not. Yeah, like 38,000%. I believe there's actually one or two more if you play around with the numbers. But the point is that, hold on, let me change this to, which of those makes sense? 38,000%, negative 23%, or 16.9%? Well, the 16.9 is going to make the most sense, and because we have a discount rate of 12%, 16 is slightly larger, the NPV is positive on all of those ranges between 12 and 16.9%, this is the one that we're going to want to use, and it's the one that makes the most sense. These others we can sort of discard as mathematical oddities that exist as a function of the fact that the cash flows are kind of weird.